Guys, my name's Joey Baker. I'm with SBS. I focus on our substation product line. So I'm going to cover a little bit of what we do there on the substation side. I presented here last year remotely. So what I thought I would do this year is just kind of give you an update of where we are, the things that we've been involved with on the substation side over the last 12 months or so. I'm going to have to put my glasses on. Okay, so what I want to do first is really just frame up when we talk about, and Dave went through a lot of this. Dennis introduced some concepts for us early this morning, but what I really want to reinforce when we talk about P4A, physical for AutoCAD, what do we really mean by that? From my perspective, P4A is an extension of, AUD. So what we've been able to do is really leverage all of the capabilities that you guys have built into AUD over the last 2 decades. All the knowledge that you've built into the application, all the learnings, all the rule systems, all the way that the features are organized, all the connectivity models, containment, all of that concept that is really fundamental to AUD, we've been able to leverage that foundation and extend that over to substation design for specific workflows that are required in substation design. So what I want to do here is elaborate a bit on substation design. It is a suite of products. We do have 2 products, our physical design, which is rooted in AutoCAD Map 3D in AutoCAD, and our protection and control module, which is a plug-in to AutoCAD Electric. So when we talk about substation design suite, we're really talking about both aspects. This is very crucial on the substation design side. The workflow is typically, but not always, segmented into different work groups. We typically have physical designers separate from protection and control designers, and those groups are segmented. And so part of what we've been working on here this year is building up technology that allows those groups to communicate better together, be able to coordinate their design efforts. Dave presented some of the capabilities in our design sync capability. One of the things that I really appreciate about our having P4A rooted in AUD is our ability to leverage the Utility Data Hub capabilities that we have. Utility Data Hub is a plug-in to into AUD. It's what allows us to connect to your enterprise systems, your EAM systems, your GIS systems. That's capability that we have not had on the substation side before we've expanded AUD into P4A. Now we have that capability, just like you have on the AUD side, to be able to interconnect or integrate into your EAM systems and your GIS systems. And so those are somewhat new concepts for our utility customers, but we're able to see what you're able to do on the distribution side, bring that capability over onto the substation side. So I think that that's going to be something that's really important for our substation customers going forward. So on the screen here, what I've got, I thought I would share a story here. Maybe just about 3 weeks ago or so, we were asked to answer what's fairly common fundamental question from a large multinational engineering firm, and that question really was, how does AutoCAD handle large, dense 3D models? If you've been around the AutoCAD environment a long time, you may have some legacy thinking that AutoCAD is really not a platform that is capable of handling genuine 3D modeling capability. So It's a very fundamental and important question that we need to be able to answer as people are making technology selections. And so we went to work to run some experiments, created multiple large data sets, created the timing videos that would show, how long it took for the P4A application to open up and handle and process large, dense models. And so we answered their questions. We had a great call with those guys. Right at the end of the call, though, they brought up this image that you see on the left-hand side and said, hey, this is a 3D substation. If you're not used to seeing or thinking about substations, this is a very large 500 kV substation that's an interconnect for multiple renewable energy facilities in Australia. And so they wanted to demonstrate what they're doing today. They're creating substation designs like this on the screen in Revit. But right at the end of the call, their design engineers really started asking about, well, tell me more about what P4A can do in terms of lightning protection design, conduit fill, what can you do for clearance checking, what can you do for pooling tension calculations, bus spans, fault current, all of these things that are vitally important for substation design and designers in general, because what they're able to create a nice looking model in Revit, but they're not able to add on all of the additional engineering calculations and things that are really important within substation design. So what I want to draw your attention to here is within P4A, and I would say within any 3D modeling application, what you can count on is that you can count on and should expect that any 3D modeling application can create nice looking visual representations. Any 3D modeling application can likely create your bill of material and get those items that are included in the model accounted for in a bill of material. What you're not able to do outside of P4A are all of these substation design specific requirements that are built into P4A. So there's a place for Revit, there's a place for other 3D modeling applications, but for substation engineering and design, the P4A application with the rules that we have built in, with the rules that you can write that are specific to your particular design organization, those are what's really going to bring the impact to your organization. So just want to really kind of draw out that P4A is much more than a 3D modeling application. It really is an intelligent design solution utilizing your organization's design standards, your organization's engineering rules and standards. Those get directly embedded into the application. So when we talk about specifically within substations, the concept of BIM for utilities, I don't have a chance to work with very many distribution utilities, so I don't really know if the concept of BIM is kind of as prevalent within the distribution engineering space and design space as it is in substations, but BIM for substation engineering and construction is a principal theme that all of our customers are really pursuing. When we think about BIM in the utility space, this is kind of the way that I like to think about it, right? That as a substation person, I can be really focused on substation physical engineering, substation protection and control engineering. But what's really important for us to think about is all of the other parts of the utility organization that really depend on our outputs, and we depend on their inputs. And so, we can get into, thinking about and borrowing phrases and concepts from BIM from other industries, the vertical construction industry, the construction industry. But for us at SBS, when we think about BIM, we're really thinking about the data flow from the design organization out to the other entities within our utility organization that rely on the outputs from our designs. We need inputs from other organizations. Other organizations within our utility space are dependent upon our outputs. So for us as a technology provider, when we're talking about BIM, we're really thinking about the terms and the flow of that data from the into and out of the design tools themselves to support the broader workflow within the utility. So looking at that BIM concept within a utility in slightly a different way, this is our working model for BIM SDS practices, our SDS BIM workflow. As I mentioned, I'm really focused on kind of the center part of the diagram here, where we have physical designers, we have protection and control designers, we have civil designers that are all focused on substation design. But there are two shoulders here that are vitally important to our success. We have to begin with content. So Dave was showing a lot of 3D content earlier today. We have tools that are available to you guys today as a customer of SBS for making it very easy for you to access 3D content, standard utility industry content. The vast majority of the content that we have available to users today is substation focused, but I suspect we could continue to grow that, assuming that the distribution design community and our friends in the gas design community who may want to move into 3D design, we can expand our content that we have available to you on our utility content site. If you haven't been there, I would encourage you to go and just see the really cool capabilities that we have there on our utility content site. We have 3D models ready for you to download today. We have configurators that allow you to build your own content there and download those models ready for consumption in P4A. Dave mentioned before, and I won't go into this, but Tilac's been working the last several months building a interface from Inventor to P4A that allows us to prepare that content in an Inventor model, in the Inventor space, prepare that content to be ready for consumption in P4A. So that's been a big improvement in our overall workflow. That content we can prepare, if your designers are used to working in Inventor, we can prepare that content in Inventor, get all the ports and tags associated with that content, and get it ready for consumption in P4A. Our substation design suite now is really consisting of 3 individual modules. We have the P4A module for physical design, we have the P&C module for protection and control design, and bundled along with that is our design sync capability that bridges between those two modules, as Dave was showing us earlier. As I mentioned, a big part of focus in substation design is integrating out to a through a BIM workflow out to either Navisworks or the Autodesk Construction Cloud, having the designs consumable, viewable, editable in the field. So having field accessible designs is a big part of what we focus on in the substation product. That led to a lot of the development that Dave was highlighting earlier in having our feature attributes and our model attributes associated with blocks so we can get those out to these other field mobile applications. So that's been a lot of work and what we've been focused on. Right now, you know, I don't really have a good answer for this, but our focus on substations, we just haven't really been integrating out to EAM systems and GIS systems at the same intensity that you guys have on the distribution side. I think my working theory is right now that, you know, from a volume of projects basis, we don't on substation sites, we really don't do the hundreds or thousands of jobs that you guys may do on distribution. So that need is not the most important need that we have right up front. Our focus is really on very intricate, detailed engineering. And so, getting to that first level, kind of that first priority first has been the focus. But it is good for us to know that we have that capability. We're built on AUD. We can integrate to GIS, and we can integrate to EAM when that need arises, right? So if there's any questions, y'all just holler out. So what I wanted to do here, and I hope I'm not going to cause any traumatic memories from our SBS folks that were involved with this, but this is really kind of instructive to me. It was fun to go back and think about what have we spent our time on in the last year. So this is really where P4A started. Our first engagement was with a utility that my colleagues across the hall on AUD had built up a really credible working relationship with the utility. That credible working relationship led to the utility being willing to partner with us to advance P4A. And so we were challenged with extending AUD to become suitable for substation design. Well, how in the world did we do that? We went step by step by step by step through every feature model that you can think of, got on the phone calls with them, delineated out in great detail, exactly how cables are supposed to be modeled, how they're going to behave, what's the difference between cable behavior in a distribution environment and a substation environment. And so being able to model cables in a certain way that's going to meet the needs of substation designers for internal, indoor designs, external designs, just being able to extend the capabilities where needed. Those were the discussions that Dave and Sarah and Jim were able to lead through, leveraging their experience with AUD, get that experience imparted into P4A. So what I thought I would do here for the next few minutes is we do have a couple of P4A customers here, but I thought I would just stand in and share some of their experiences, but mainly want to share with you my takeaways from the implementations of P4A that we've been involved with over the last 12 months. And so I just want to give you guys some vision, especially as you go back to your offices, you have a chance to talk to your colleagues that are on the substation side of the business, and share with them that this could be, if they're interested in kind of moving down the AUD road. I would think that they're seeing a lot of the cool stuff that you guys are doing, and maybe trying to figure out how do we get to doing something similar. So I have 4 customers that I really want to highlight here. There's a lot of similarities. There's a lot of uniqueness to each of these. A couple of things, and a lot of this is probably going to really mimic, in a way, what John Marie was sharing with us this morning. So what I've really picked up on here and what I'm trying to convey is some of the takeaways that I've seen over the last year that really are making for a successful substation implementation. This is probably true for technology implementations across the board. Certainly starting with strong upper management, leadership, and commitment. Having a dedicated team that is not only dedicated, but they're capable and they have the decision-making authority. So there are a lot of decisions that need to be made. There's a lot of trade-offs that have to be made in any implementation. Having the right people in the right seats with the right authority to make the decisions is crucial. I do think that beginning with change management in mind, so anytime that we begin an implementation and we beginning with the deployment in mind is probably one of the most crucial aspects. On a lot of surfaces, through looking at it a lot of different ways, I think the technology part is really the easy part. The change management and getting people on board, that's really the hardest part to work on. So not to diminish all the hard work that goes into the technology, but we can have the best tools, but if we haven't really advertised that, as was being said earlier this morning, if we haven't gotten excitement around that, then people may not gravitate towards the tools. I think one thing that's been really surprising for me is just quite honestly how capable customers are, right? So this is not, as I hope it's been a theme throughout today. Dennis mentioned implementability this morning, and so that is a huge push within SBS. We are looking to empower you to be able to self-maintain your configuration, to be able to make those updates, to be able to tune your rules, to be able to recognize, hey, we have these changes, these new inputs, be able to maintain that template. And so it's been really surprising and in a very pleasant way to see how capable our customers are, how quickly they can get up the learning curve. I mean, we're talking about folks that have never been, substation people are not distribution people. We don't, at least I'll speak for myself. I did not come to the substation side understanding how, GIS modeling and feature classes and all of those things are organized. There's just a huge learning gap that has to be overcome. And so it's been really surprising to me how quickly our customers have been able to get up that learning curve, understand, and be really attentive and capable within their own configuration. NV Energy, one thing I should emphasize about all of these customers is, remember, we're talking about two separate groups, two separate products being implemented simultaneously. So this is quite remarkable, in my opinion, for organizations to be able to go from training to having models like I'm showing you on the screen in just a matter of months. They really gravitate towards it. I think that does speak to, from a substation technology perspective, we are with the P4A technology. Quite frankly, we're just running circles around what we've been able to do over the last 10 years, working with various organizations to implement substation design technology to get to a place within just a matter of 2 to 3 to 4 months where you can have these kinds of models that you're able to put together with your structures, your equipment, your data embedded directly into the application. Really is remarkable. I say here, no experience required. This is probably true of all of our customers, but was certainly true of NV Energy. They were designing in 2D. No 3D CAD experience at all within the organization when we started implementing with NV Energy. One thing I picked up here is I think deadlines matter. Put in those, hey, I need to report to the VP checkpoints, okay? Make those things public, make them big, make them important. I'll share this. Jim was helping our client prepare for that VP presentation just over the last month or so. And Jim probably made more progress working one-on-one with the client in 2 to 3 weeks than we had made kind of as a collective group effort in the previous 2 months. I have some kind of pros and cons around that, right? But the results do speak. It's hard to kind of see a one-to-one, it's hard to manage all of that. But at the same time, I think that there are some things that we can learn from that as a part of a process. Don't be afraid to pivot, change. We have to figure out how to accelerate our implementation, and let folks get on and work one-on-one with the SBS team. One other thing that's been a real big learning point for me from NV Energy is just the persistent question till they really understand. Okay, because once you fundamentally understand how AUD works, how the models are structured, and what the values within the model tables really mean, you will start to understand, how things, what they represent in your design, how to improve your design, how to improve the efficiency, and those kinds of things. So don't be afraid to ask. Your SBS team is here to answer questions, show you different options that you may have for accomplishing what your goals are. We're working with SCE. This has been a bit of a unique engagement. It's been a bit fractured. We've had various kind of starts and stops along the way. One thing I would say here is just be flexible. You guys are part of a design organization. These are technology projects. Each organization, each utility is different. Is this a IT project? Is this a business unit project? You likely need to work together in some way. So figuring out how best to manage that within your organization, manage within and work within the constraints that you have so that you can keep making progress. What was really surprising here is that SCE did not spend a lot of time creating content initially. They went to our utility content site. They were able to download. They were able to create content. They were able to modify content to really get that starter set of content that you need within P4A in order to be able to understand what's P4A doing for me? What do I want it to do? Here's a little bit of a different tact. I wasn't real sure how this was going to work out, but I've been very pleased with the results that SCE's been able to gain. They brought in one of their preferred prime contractors, set them side by side with themselves as they went through P4A implementation. The contractor's been joined at the hip with us for the last several months, creating content. They've been building the library in Inventor. They've been porting that over to P4A. Now with this with SCE, we have a humongous content library that SCE can start to utilize within P4A. They can start to test all of that. They can start to add the data. So that aspect, bringing on their contractor early on, has really been a big benefit to SCE. The other thing that we did here at SCE last year is we really insisted that, hey, let's pause, let's take in parallel with P4A configuration development. Let's take a look at the longer term roadmap. And so we had Sergey come in as our architect. He spent quite a bit of time with the substation team, the IT team, and we did a detailed roadmap for SCE, which has really served, for over the last 12 or 18 months or so, has served as our kind of guiding principle on exactly where SCE is looking to go. So as long, their schedules change, their IT constraints move around, but we still have our roadmap. We understand where they're trying to get to. They're trying to get to, Vault and Autodesk Construction Cloud and LiDAR and brownfield and all those kinds of things. But having our roadmap allows us to really understand ultimately where we're trying to get to. So I would say that that's, really important takeaway from the last year is be sure that you can kind of lay out your long-term vision while you're also working on the details within P4A. We have an engagement going with AEP now to implement P4A along with PNC. This has been a drinking by a fire hose kind of an implementation with these guys. They just started on the P4A technology implementation in January of this year. We are now with AEP doing, or we'll be doing 11 different pilots with 11 different contractors. So just the velocity at which they've been able to understand P4A, get it configured to a point where you can hand it off. You can have people really creating genuine design projects in a short amount of time. That's been a remarkable achievement for that team. The other thing I would say there is there's been a couple of lessons learned here. What I've really liked about the AEP implementation is they have really strong leadership from the top down. We can end up on calls that have lots and lots and lots of people. That's not always productive. So one of the things that we've really been able to see is, be willing to segment your work groups. So have, folks focused on getting the content created. Have different groups focused on getting the rules written and those kinds of things. So having, smaller teams does allow us to make quicker progress. That's been pretty important there. So have great IT support. We have great project management support. Both of those, you may snicker at that from time to time, but from what I've seen is both IT and project management can allow us to, if we run into constraints, they have methods to allow us to break those constraints. So that's been a really important aspect of the AEP implementation, is having a good, strong working relationship between the business unit and the IT organization and the project management organization, all of those units really working together for a goal. Again, that goal has been established by strong executive leadership. Okay, I will say, when we keep implementing with customers, there's lessons that are learned. So, one of the lessons that we've learned here recently is, and we're working with our partners at Autodesk here, actively working to figure this out, get this resolved, is that there are some technical challenges related to large data coordinates and the impact that they have on 3D graphic representation. That's why you may notice, if you're a substation person or used to looking at insulators, some of the graphics here within the image that I'm showing are a little bit fuzzy. These are things that don't surface until they surface. So, we're working on both the technology side, fundamental technology side, and the kind of the workflow to minimize this type of occurrence. But, I think here at SBS, you've got people, we're very close to our customers, so we receive that feedback very quickly. We take that feedback, we run the experiment. So, best thing, the first thing you'll hear is, hey, send me the drawing so I can see if I can replicate that issue. We'll figure out, what's going on, what the root cause is around that. So there's going to be things that pop up as we keep extending the capabilities of AUD. But I'm confident that as those technology things pop up, we will figure out the right workflows and the right technology to support that. So Let me see. So I'm just going to recap real quickly. My takeaways from this last 12 months or so on, as we've seen our customers really be very successful in implementing the P4A technology. One is you have to have really strong executive sponsorship. I think, and the hardest thing that we see consistently across the board is customers having the ability to dedicate resources to the implementation. If I could put that in, kind of as a almost a mandatory requirement, I would. I think it makes a huge impact to having dedicated resources that can really focus on the implementation, learning the technology, learning what will work, what your organization is looking for. So begin with change management in mind. We talked about that. Again, be creative, be willing to pivot, have a plan, but be willing to modify that plan, be agile. We understand things are outside of our control. Some budgeting things are outside of our control. Conflicts with IT, other projects getting priorities, those kinds of things. Just figure out creative ways to work within the constraints that you have. I would say begin with assuming that you will want to maintain your own configuration. Figure out how to have that capability, build those skill sets in from the very beginning. Again, finding the right balance within each organization between IT and the business unit leadership, I think, is really important. Focus on the design tools first. That's really what we've done on the P4A side. So we've had the luxury in some sense of not having to really focus on integration to GIS and integration to SAP and those kinds of things. We've been able to focus on the design tools. So we're able to build that fundamental capability from the ground up without really needing to focus all that extensively on the integrations out to. Oh, we got a dead mic. Oh, I'm sorry about that. How long's it been dead? The whole time? Did y'all hear anything I said? Okay. Jeez. All right. I'm not going to talk about design sync, so Dave covered that. Other than I'm going to bring it kind of boomerang to you a little bit. I would be really encouraged to hear from a design sync capability. Your perspective, you bring a different perspective than I do. So I think that there's likely a lot of use cases outside of substation design that may be beneficial in the work that you're doing. So we would encourage you, just to reiterate what Dave said, we want to hear your use cases. Give us something to think about. We can go back to the laboratory and start working on those kinds of things. So, Pat, that's probably all I got. If there's any questions, I'll. Okay. I feel like Phil Donahue. Does anybody remember?
So can you briefly describe the advantages of a utility implementing, the substation, the P4A and the protection and control specific to the utility advantages, and then also advantages for the consultants supporting those utilities?
I think I want to go back to this. So Jared, from my perspective, for a utility, the benefit of P4A is really beyond the design tool, okay? So the benefit is really in having single source of truth data. That's probably a comment all you guys are after. It's in the benefit of having avoiding redundant data, just having a seamless, if the ideal, right? Seamless connected data from your design throughout the rest of the organization. There are likely other 3D modeling tools that can, in some way, get you a really nice, pretty picture of a substation, but that's not really what we're after. We're after being able to connect our substation design office to all the remainder of the ecosystem. The other thing to keep in mind about substation is we have two components. We have protection and control. We have physical. Those are at least two. There's probably others. Civil design. So being able to connect your physical design and your protection and control design on the same platform, rooted in AutoCAD, allowing us, as we were showing earlier, to be able to seamlessly navigate from a physical design representation of a breaker or disconnect switch to the protection and control representation of that same device. That, we think, is going to be a genuine game changer within the utility and within all the engineering firms that support the utilities and the renewable energy developers. That technology or that capability, is beneficial whether you're a engineering consultant designing a renewable energy facility or whether you're working for a large investor-owned utility. So,
AUD, also AutoCAD, right? So AUD design, you're using AUD. P4A design, you're using AUD. There's no reason you can't jump directly from substation into distribution and show all of your connections and circuit exits and everything else from a full 3D model, connected all the way through, which is like the holy grail of design, right? To be able to go from generation substations to subtransmission to transmission substation to distribution to be able to do that all in one platform, in one tool, in addition to the PNC stuff, is, like, it really makes you think, right?
any other question? Yeah. Oh,
But yeah, good presentation. I'm just kind of curious. You talked quite a bit about content, which is a key component of P4A. I mean, I know the value from a consultant's perspective of the design tool and of content. How do you see the manufacturers playing in to helping utilities forcefully leveraging their position to get that content from their manufacturers as they start the migration to, say, P4A?
That's kind of the biggest question we quite honestly haven't been able to crack as well as we've wanted to, right? So in the distribution space, same as in the substation space, we have the OEMs, the manufacturers. We are very incrementally seeing the manufacturers be more and more willing to provide content to our community. That's been a fairly hard row for us to hoe over the last 5 years or so. I think what it really takes is it takes our community working together to continue to ask, insist, hey, we need these models from you. It's a part of our overall workflow. I think you as a utility, the more pressure that you're able, positive pressure, that you're able to put onto your manufacturers to have them provide you this content, I think it will just get weaved into just kind of the expectation that we have today, right? The manufacturers no longer send you Mylar drawings, they're sending you PDFs, right? So we can see the manufacturing community mature into being able to accept as a expected deliverable to you as a purchaser the 3D content. We can instruct. As a matter of fact, we have guidance on our website today that you can go and send to your manufacturer, take it, make it your own, modify it on, hey, I don't need 100 megabyte file of your device, right? Strip out all the stuff that you think is proprietary. I really need the shell so that I can tag it, so I can know where to connect to it. I don't need to know all the brains and those kinds of things that are proprietary to your technology. But Dwayne, I think we just kind of have to, as an industry, keep putting that positive pressure on our manufacturing community. Again, and go to our utility content site, tell me, hey, we need this, have you thought about this? Especially you guys in the distribution space, we haven't focused as much on that type of content, but as we have P4A and AUD start blending together like Jim was talking about, think about those projects where we have collectors, either underground or overhead collectors, or we have distribution lines, and we want to have a more seamless model. You guys may have that opportunity to design your projects in 3D, and we would have more and more need for 3D content going forward for distribution projects.
Do you have anything in the pipeline for doing brownfield workflow with substation and utility?
That's a good, tricky question. So I'll share with you my thoughts on that. So Jack's asking about brownfield. When I think about brownfield, I think about 3 different starting points, okay? So one starting point can be you have, legacy 2D AutoCAD drawings. They're DWG files, right? We can also have, so most people would have that as a starting point. We can also have, raster images, scanned drawing images from your flat files, from the job from 1975 before AutoCAD was in your environment. We can also start today more and more from LiDAR images or point clouds. So I think that we can really begin. Jim's got some great workflows that he can share and shows as a part of training on how to start a P4A design from either a raster image or an existing DWG file. If there's any existing microstation firms, you may have legacy microstation drawings. We have workflows to show how to convert those over and begin a P4A design within a legacy DGN. Okay, so we don't, on those 2 fronts, Jack, I don't know that it's really a technology. We have more of a workflow that we would go through to implement P4A intelligent objects into non-intelligent legacy brownfield designs. On the LiDAR front, we can bring in LiDAR images. We can place P4A intelligent objects within a LiDAR point cloud brought into AutoCAD through recap, bring it into AutoCAD, and then start placing P4A intelligent objects on those devices so that you're able to use that as really a backdrop, your image as a backdrop as you want to make modifications with P4A, with your P4A models that have the intelligence that are driving, the analysis and the bill of material and those kinds of things. So I think it's probably, especially on the LiDAR, as Dave mentioned, that's a big focus for us, is to really figure out what can we continue to do to improve on that workflow to drive more and more value to brownfield.